Okay, let's talk about references in Python. Well, what are references? In Python, variables don't actually hold a value. So that might seem counterintuitive, right? Because variables are associated with values, values are associated with variables, but that's actually not the case in most languages, actually. If I say x is equal to 10, yes, when we print out x, we get 10, right? But what's actually going on behind the scenes? X does not hold the value 10. So if I get in this example, we say x is equal to 5, x does not actually hold the value 5, or any binary equivalent to that. It actually holds a memory address. So this memory address points to a certain location, or this memory address is the location that contains 5, right, in memory. So this address is called a reference. So Python has references, gives references to variables, not the actual value. So x holds a reference, and that reference points to 5. So when assigning variables and passing variables through parameters, functions, assigning it to different variables, other variables, Python always passes the reference, not the actual value. This is known as pass by object reference, which we will go through in later slides. So can you predict what will happen in this example? We have a class called person. We have an init method, as we covered last class. It's required to make an object, right? To make an object of, or an instance of a class. We take in the name, we assign that to an instance variable. We have a change name method that changes the name. So if we have x is a person object, and we pass in Bob, we set y is equal to x, we do y.changeName to Joe, and we print x.name. So just looking at this, you might think that, oh, so x is equal to person, y is also equal to a person. We changed y to equal to Joe, but x has never changed, right? So x should still be equal to Bob, right? So x.name should be Bob. Well, that's not the case. It actually prints Joe. So why does it print Joe? Well, when we say y is equal to x, that's where this issue is coming from. When we say y is equal to x, y holds the reference, the same reference as x. So the same memory address as x. So y is actually equal to a person, Bob, the same person, Bob, as x. So not two copies, not two separate objects that have the same name, but the exact same singular object, person, that has the name Bob. So let's talk about immutability then. We saw how references can lead to unexpected behavior in our code, right? Well, what if we do the similar things with ints, floats, booleans, strings, and tuples? Well, it's not the same when we do it with these data types. If I set x is equal to 10, y is equal to x is equal to 100, and print y, looking at the previous slide, it's natural to think that since y is equal to x has the same reference, that means y.changeName to Joe would also change x. So in that kind of thought process, when I do x is equal to 100, y should be equal to 100 too, right? Since they contain the same reference, and I'm changing the value at that reference, so y should be equal to 100. But that's not the case. Again, so y is actually equal to 10. So why does this happen? Well, this is because they're immutable. These data types are immutable. So an integer is an immutable data type. We're clearly changing the value of x to 10, to 100, from 10 to 100, right? So shouldn't y change too? But that's not how variables are stored in Python. Let's talk about that. When you create a variable in Python, Python actually allocates a certain amount of memory to that variable, but depending on the data type and other factors. So it allocates a memory at a specific address and writes that value to the memory spot. So let's say we have an address called J56833307. When we do x is equal to 5, 5 is written at that address in memory. So whenever we want to get the value 5, we go to that address in memory. So what does x hold now? Does x hold 5? No, x actually holds the memory address. So notice how the address is J56833307, X now holds J56A3307. So when you print X, you should say, oh, why doesn't it print J56A3307? That's because Python doesn't do that. Python obviously, the whole point of that is holding the value 5. This is all concerning the backend and what Python does behind the scenes. So Python actually holds the value or writes the value 5 at J56A3307 or any other memory address that might be created, and X holds that address. So when we want the value 5, we go through to J56A3307. So that's what Python does behind the scenes. An easy way to remember this is with boxes. When you create a variable in Python, Python creates a new box. This box has an ID or how to get to that box that differentiates that box from other boxes, and this is the memory address. X holds that ID now. So when we want to get to a specific value, we look at X, we look at the ID that X holds or the memory address that X holds, we go to the box that has that ID or memory address, and then we get our value. So those are the steps basically what Python does. Let's talk about dereferencing though. So referencing and dereferencing is all what Python does behind the scenes. You don't usually have to worry about that in your code, but understanding that is very important to become a better programmer. If in this example, we set x is equal to 1, 2, 3, 4, a list that contains 1, 2, 3, 4, we have y is equal to x, then we append 5 to x, and then we set x is equal to 12. So a lot of stuff are happening here. A lot of things are happening here. So let's go through the process step by step. We set x is equal to 1, 2, 3, 4. So now x points to some place in memory which contains the list 1, 2, 3, 4. This is the reference. When we set y is equal to x, y now points to the same place in memory as x. So y doesn't point to another location in memory that contains 1, 2, 3, 4, a list containing 1, 2, 3, 4, but it points to the same exact location in memory. So it's a new reference to the same exact memory address. So when I do x.append 5, we're modifying the value at a specific memory location. So we're modifying the value at, let's say this is A, B, C, D, E, F, G. We're modifying the value at that memory address to 1, 2, 3, 4, 5. Instead of 1, 2, 3, 4, we're changing it to a list that contains 1, 2, 3, 4, 5. So now when we do x is equal to 12, what happens? And also notice how y still points to the same location in memory, which now has a modified value. So when we do x is equal to 12, setting x to a new value creates a new box, right? It's not changing the value of that reference. So when we say x is equal to 12, we're dereferencing x from 1, 2, 3, 4, 5, the location that contains 1, 2, 3, 4, 5, and we're referencing it back to a different box that contains 12. So you have to understand, we're not changing the actual value at a location that contains 1, 2, 3, 4, 5 to have 12. We're creating a new box that contains 12 and assigning that to x. So now x doesn't point to 1, 2, 3, 4, 5. X points to 12. So it cannot point to both, obviously, because then there's ambiguity, but x points to 12. So at the end of all of this, what is the value of 5? Or what is the value of y? Well, y still points to 1, 2, 3, 4, 5, right? Nothing happened to y after we did x.append 5. So y at the end of all this is equal to 1, 2, 3, 4, 5. So it's good to understand how Python actually does references and dereferences variables, because this can lead to unexpected behavior in your code and you'll be able to catch some errors quickly. So dereferencing continued. Let's say we want to delete an object in Python. How do we do that? Well, Python makes it pretty easy. It has a del keyword, del. This helps us, it doesn't actually delete the object, but dereferences it. So we're talking about dereferencing as removing a reference to a certain memory location. So Python removes the reference, removes any reference that x or whatever variable you pass in might have. So when the garbage collector, a Python internal tool, goes along and gets rid of that object later on. So the garbage collector goes on frequently and deletes or removes any objects that don't have any reference to it. So when we do delete x, Python deletes that object from memory because it has no references to it, right? So we have a value that has no references to it. That means it can never be accessed. So Python deletes the reference and deletes the object as well. So let's talk about immutability again. The immutable data types were integers, floats, booleans, strings, tuples. I'm pretty sure that's it. Integers, floats, booleans, strings, and tuples. And what happens there when we are assigning it to a different reference? Well, when we do x is equal to 10, again, we might have a memory address called AD3627FH. So x does not hold 10, remember. X holds AD3627FH. And the value at that memory location is 10. So when we do y is equal to x, y also now holds the same reference, right? Y holds AD3627FH. Say the same one as x. But something's different. When we do x is equal to 15, the value at AD3627FH does not change to 15. That is important to remember. It does not change to 15. We create a new box, a new memory location, possibly KLJF24JD, that now contains 15. So y still contains 10 because it points to AD3627FH, and x now points to 15, or x now has 15 because it points to KLJF24JD. So notice how reassigning x changes the address of x. It does not change the value located at the address of x. And y still points to the same address, which means y is equal to 10 and x is equal to 15. So in our code, it might be hard to understand where all this is coming from. How do we check if something's equal to something, if a variable has the same reference to another variable, and so on? Well, Python makes it easy for that as well. We can use the is keyword or the equal to operator. So the equal to operator stands for equality. It checks value equality. So if I were to say x is equal to 5, y is equal to 5, x equal y, that would be true, right? Because 5 is the actual value, 5 is equal to 5. But is, on the other hand, checks reference equality. So whether two variables point to the same memory address. So if I were to say x is equal to 1, 2, 3, 4 as a list, we look at in the example, and y is equal to 1, 2, 3, 4, and z is equal to x. If I print x is equal to y, the list containing 1, 2, 3, 4 is exactly the same as another list containing 1, 2, 3, 4, right? So the value is the same. And same with z, because z is just the same object as x, so obviously it will contain the same value as well. But when I do x is y, notice how y is a different object. It contains a different location in memory, and by chance, because we set it, it has the same value. But it does not contain the same reference. So x is y is false. But notice when we do z is equal to x, we're giving the same exact reference as x to z. So now z contains the same exact list, 1, 2, 3, 4, that we specified up here. So if we modify x, we also modify z. So when we do x is z, that's true because it contains the same reference. So let's recap. References and dereferences can easily cause unexpected behaviors in your code. It can cause issues, bugs, or just weird behavior in general. So it's important to understand how Python handles variables in order to avoid these bugs and catch them in the early stages. Obviously ask questions to your instructor. This is a review, so it's important to do some research on your own if you're not understanding fully, but references is definitely an important topic in Python and everyone should know it. So let's look at these examples. Example 1, we have x is equal to 1, 2, 3, 4, y is equal to x dot append 10, and x is equal to 12. So what if we print y? Well, when we do x is equal to 1, 2, 3, 4, s contains some memory location that has a value 1, 2, 3, 4, right? So when we do y is equal to x, we're assigning the same exact reference of x to y. So now y contains the same exact object 1, 2, 3, 4. So when we do x.append 10, it modifies that value, right? So now x is now equal to a list, or y is now equal to a list that contains 1, 2, 3, 4, 10. So when we do x is equal to 12, remember, we don't change the value there. We actually make a new box and change that reference. So now y is equal to 1, 2, 3, 4, 10, and x is equal to 12. So that's what we get. Y is equal to 1, 2, 3, 4, 10. In the second example, we have x is equal to 10, y is equal to x plus equals 1. So notice how we're dealing with integers, so these are immutable data types. So x is equal to 10, that works. Y is equal to x. So now y is equal to the same exact reference as x. So y is equal to 10. But when we do x plus equals 1, we set x to a different reference, to a different location in memory that contains 11, because 10 plus 1 is 11. So we do not change the variable or the value located at memory address of x to 11. We create a new box or new location in memory that holds a value called 11, and we set that to x. So y is equal to 10 and x is equal to 11. So notice we print y, we get 10. Now the third one, x is equal to 1, 2, 3, 4, y is equal to 1, 2, 3, 4 as a list, x at index 0 is equal to 10, print y. So looking at this, like once again, if we just follow through the steps, x and y both contain the same value, yes, but they contain different objects, they contain different references. So these are the same value, yes, 1, 2, 3, 4 is equal to 1, 2, 3, 4 as a list, but these are two different objects in memory. So when we do x at 0 is equal to 10, yes, we're changing the value of x, but we're not changing the value of y. So y is still equal to 1, 2, 3, 4, which is what we get. So that was referencing and dereferencing. That was referencing and dereferencing in Python. It's very important to understand this topic because it'll come in later in your code when you're dealing with objects, especially in object-oriented programming. When you're dealing with them, you can easily run into referencing issues in your code. So it's important to understand where they come from, how Python handles it, so you can be a better programmer in the future.